Welcome. So it's time for another coding challenge, and this stream is for entertainment purposes only. Let's see if everything works as intended, and if so, seems like that. Yep. So yeah, let's see which problem we are not going to solve today under 40 minutes. And see, pick one. It's obviously hard. Now we are going through all mediums. Interesting. So before I had like 5 or 6 hard problems in a row. Now it's the third medium problem in a row. Seems like third problem that we are not going to solve. Given an array of integers nums and an integer k, a continuous subarray of nice subarrays is called nice if there are k odd numbers on it. Return the number of nice subarrays. 1, 1, 2, 1, 1. The only subarrays with 3 odd numbers are is 2 and ah subarray. So we can't concatenate parts of it. So it should be one piece of array between some indexes that should have 3 odd numbers. All right. And well, to be honest, if we have 4 odd numbers, right, then I see. So my logic was just count all odd numbers in the array, right? And then say the total number of it. So obviously if it's lower than k, then 0. If not, then whatever numbers of it you have, minus 3, right? Yeah, it's 1. But I see. Interesting. So in 4 we have 3 and 3. Okay, let's go to the whiteboard and see okay, so example 3 is actually confusing a little bit. So we have 2 odd numbers, but how many? So we have k, we have length of array, and we have number of odd numbers in this array. And we need to say how many subarrays there. Oh, continuous, or if there are continuous or not. Well, instead of doing permutation way, because num's length is 10,000, no, sorry, num's length is 50,000, and from 1 to 10,000 is whatever num is. And k is definitely less than num length. And many people like it, so it seems like it's easy. It's not that hard to solve once you crack something. Maybe it's dynamic programming, maybe not. I don't know. Let's just see. Let's start with first one. All right. So how can we tackle it? So we have 1, 1, 2, 1, 1. So I doubt that there can be a formula because it depends how odd numbers are following and where they're allocated. So most likely there should be like a sliding window slash solution where we count. So obviously if k, so the minimum subarray size is k, right? So if k is 3, the minimum subarray is k. And so how many k's there is this, this, and this, right? Because we have 5 minus 3 plus 1. This is like number of k size arrays. But then we might have 5 minus 4, right? Plus 1. So this is what? This is 3, this is 2. This is k plus 1. So k plus 1 is this, and this. This is k plus 1. And k plus 2 in this case is this one, right? And we can get higher because in this case, so 5 minus 5 plus 1 is, all right. So we can have but the question is, do we really need to go all the time with these sliding windows, right? We can keep increasing the window size, right? So algorithm 1, start with k with k to k plus n that is less or equal than length, right? 2, slide window to count odd numbers. Increment if equals to k, right? The problem of this, that when we slide, we subtract, when we slide is we basically do this in linear time every time, but then the number of cycles for the k is somewhat is from k to the length of the nums, which means it's roughly quadratic in the worst case. If k is closer to 1, so it's significantly lower than the size of the array that we check. I wonder if there's something faster, right? So let's see these two, right? So these two, so if you do this recursive way, technically corresponds to this one. So if we know the number of elements here and number of odd elements here, all we need to check is one element here and one element here. So it's a constant time. Check. Once we count here and there, right? And if we did check here and here, and similarly here and here, now we don't remove this element, we remove this element on the right. And this to decide how many odd numbers here, right? And if so, yeah, I think I might know the way we sequence this thing. Okay. Let's try recursive way of going from tinier windows and then going larger, larger, and larger, and see if we pass the check. So the complexity wise, we merge two in constant time because all we need to determine is this and this, right? So theoretically, but there will be logarithmic amount because we kind of scale from tinier to larger, 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 and larger windows. So this should be, I would imagine, recursive n log n solution. That's my feeling. But let's see if it turns out to be true. So going to default scene, we let's have private Discord. Num of subarrays internal. Or let's say subs internal. So we save a little bit on the naming. So technically here we won't change the vector itself. All we need is just a const vector. Here we say const between vector, const vector int k. So we need start and end. And we can say that end and start are both inclusive, or maybe end is not inclusive, so it's n minus 1. Yeah, let's assume they're both inclusive, so we don't really care. Okay, int k, we don't change, and then we have int start and int end. Or we can say it as I and j for simplicity. All right. So this is recursive way. So we say if So if it's, let's say 0, 2, 3, 4. Yeah, so let's say I inclusive, j excluding, right? J excluded, I less than j, always. We do not consider the case when we have just one element, do we? We can check. So it's, because it's boring, so we don't need to do this. So it's, if k equals 1, let's say, if k equals 1, right, it's basically number of odd numbers. If k equals 1, if k equals 1, return num of odd numbers. We'll do this later, right? So this is the corner case. So we always can imagine that I is less than j. It's always less than j because it's obviously, even if it's one element, it's just not included. All right, so then here we go. So if j minus I, which is length, right, equals k, right, then we return a number, we return 1 if number of odd elements equal k. And this is obviously will be linear thing, so we can just say for int ij are not great. Let's say start and end, whatever. Start and exclusive start and start and start int I equals 0, I less than end. Not 0, it's start. We start from start. Then it says an end and I plus plus. We say if we need cnt int odd num. The problem is so I need something to count, right? Because theoretically, once I return the number of odd numbers there, I might return it just once, right? So I don't need to recompute the second time. So let me see. Should I have pointer as well? Int pointer odd num, right? So we say odd num plus equal nums I percent odd. So if it's 0, right, then we return 0. Otherwise, it's odd number. So if the remainder of 2 is not 0, it's odd number. Okay, so we add it to the odd number. Then we return odd num equals what? K. It will be casted to, so if it's equal, it's 1. If not, it's 0. Got it. Now else it means it's bigger than that. We do this. We say int odd num left equals to 0, odd num right equals to 0, and then we return what? Num of this, right? Obviously nums. What? Our start will be, let's say, start, and end will be -1, right? So it's first left, k, and odd num left. Plus, same thing, but now it's start plus 1 and end, right? Odd num right, and then we need to check two things. Int or should we say int num nice left, num nice left equal to this guy, right? Same for the right thing, nice right equals to this guy. And now we know how many odd num elements were in first one, in the left one, in the right one. And then we need to say that overall 1 Ah, so how do we do this? Let's say we take the left one, right? And all we need to do is check the end minus one element if it's odd. All right, so yeah, let's do this. So it will be completely weird, but return this plus this. Now maybe like this. And plus, let's say odd num left plus what? We can just say the remainder of nums and minus one because it's we are not including the end element, right? It's excluding it, so the actual last element will be n minus one. All of these equals k. Yes, then one, otherwise zero. And that's it. This is the entire program. Ah, the only thing we're missing is the amount of is basically we need to say that odd num is equal to these two, right? And odd num is equal this thing. So yeah, I would imagine we still need to do it separately. The int num nice left equal to this int num nice right equal to this and odd num equals to this, right? So having this, we now can say num left, num right, and odd num equals k, then 1 or 0. This is it. Okay, so we have about 10 minutes. So let's try to debug first. So I guess this is, you don't need this special case. All we need here is just to can say odd num 0, right, and then we return nums 0, num size k. We can also say it's const, so it's actually, let me just make it the last one. I wonder, whatever. So it's k, and what's left? Odd number, right? So it's this. Okay, so it's or and log n. So at the first iteration, we do basically near time, and then we return. So the overall is n. Then we go one layer above. Do we count? I don't think so, right? We just, all we do is basically, so it's a constant operation at this time. There's no cycles for, right? It's only once. So it's n. When we go to the lower level, then we go up one level. So we joining them. It's constant, 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 constant. So it should be n plus log n. It's actually even better. So it's basically linear time. But let's see. Space, what we're using, some integer numbers. So one integer, some sub-integers to count this odd number, right? And that's it. Or alternatively, we can return the vector of integers, of two integers, so we don't mess with the pointers. And then, or maybe the pair of integers, where the first one is the number of nice subarrays and the second one is a odd number, right? So in this case, we can return. Oh yeah, maybe let's, for simplicity, do a pair of int. So we are not messing with this one, let's say first. Then we don't need this, right? And then what we do here is basically, let's say odd num 0, and then we say num plus return make pair odd num equals k and 0, 1 at this point, and odd num, right? This is it. And then we don't need this one anymore. And here we can say we need the pair of, or we can say auto, right? We know that this is a pair, auto. Nice this, auto. Nice this, because we know that this returns the pair. And then return names left first, right first. So it's make pair again. Yeah, let's also use int odd num, goes odd name left second plus this, and then we say odd num goes k this, and as we know, we should return also odd num. All right, so let's see. If this looks slightly nicer, we have 5 minutes left. So let's quickly go through the example 1 and example 2, right? Example 3 is too hard to. Okay, let's start with 2. It's simple one. 2, 4, 6. 2, 4, 6. So k is 1. K is 1. Right? So obviously start 0, 3, 1. So this is at first, we can say 0, 3, and 1. That's how we call it. Oh, sorry, why 0? And nums. Nums 0, 3, 1. Yes. That's how we call it. So three minus 0 not equal k. So we go here, we say subarray of 0. Obviously nums, I will skip this, 0, 2. And what? And 1 here, right? Oh, we don't need this thing anymore. Right. So we can just close it here. So this one will be 1, 3, and 1, right? So 2 is still not k, so we go to the next one, where we now have, let's do this, or this actually. 0 from 2 minus 1 is 1, okay, 1, right? And this will be on the left side, another subarray, 1, 2, 1. Right, so for 0, 1, we subtract is 1, right? Say, okay, 0 to 1, so it's just one element, basically. Nums I, %2, if it's 0, and it is, then it's 0. We say odd nums plus 0, it remains 0, and we say odd nums equal k, 0 doesn't equal 1, so it will be 0, and odd num 0. So we return 0. Same for this guy, because 4 divided by whatever it is, right? So one issue I see here is, let's say this is 0, 1, and 1, and this is 1, 2, and 1. And we already technically calculated 1, 2, and 1. So should we add memo for indices? Like if it's 1 to 2, then this is the pair you're looking for. Could be, could be. All right, we have some time. Okay, let's speed it up a little bit and see if it works. Like unordered set, let's say memo, or do we want to have an array for these guys? Whatever, let's do memo. Let's do unordered set of string to pair of integers, int. All right. Then we will also pass, it's not const, it will be memo of this thing. All right, but let's say reference to it. All right, so here we say memo. Then we check num so what do we check? If, let's say, if memo find, say toString start plus toString end -1, right? Not equal memo and, so we can actually say explicitly here, nice left. Let's do this. Whatever. So if it's there, right, then we say num nice left equals what? Equals equals memo. Let's say string left key. Do this, right? So we specify if left key, then memo and, then we say memo left key else we do this, right? Can I say it here? And then memo left key equals num Nice, left. All right, so then we don't need this any longer. I think so. So then we also do same thing here. So check left, then check right, check right. Actually, you know what? It's not the best idea. So let me copy this because it's double of the code, right? So the better version of it. So let's keep auto and stuff. So all we need to do is this. So we have this key, let's say key, start, end, right? If memo find key not equal memo end, right? Return memo key. That's it. Now, before we return anything, we should say auto result equals this. So this will be else if. So yeah, let's do this thing. Else if result return. So we say memo key. We don't need result. We can just say memo key equals this, right? And then just return memo key. Same here. Yeah, it's way better. And then return memo key. So we made it a little bit worse on the memory side, but now we are really linear time. Let's see if it works. So we debug it on one example, 40 minutes passed, and we did some memory thing, even unordered string pair does not provide a subscript operator. Seriously? I thought we can do this, or we always can say, because we know that this is not the first one, right? We just say find key second, right? So this guy and this guy and this guy. So if you run it, we will now complain here, right? Why it doesn't? Yes, it should be iterated, right? And you say second. Oh, Jesus. It's an ordered map. That's why, no, it still should be just key. Yep, that happens. Um, so technically, we may also save on this line because it's the same line, so we can just say return memory key here, right? Don't do anything here. Do nothing. All right, so run code. Too few arguments to function call. We should say memo. It's now nice left. Or we actually just can say left, right, then say here left, and make pair left first, right first. So we don't have 3 arrows here. All right. Yep, looks fine to me. Output 1, expected 2. Damn it. Oh, man. This is stupid. Why? Let's see here. Cout. Cout. Start. Start. And num nice equal memory key first, and finally num odds memory key second. Second and end the line. Zero to 3, all right? 0 to 3, num nice 0, num odds 1. This is weird. Num odds should be 2. Why 1? Oh, did I miss? Maybe I missed odd number plus, all right? If nums, should I just say this? What's the reason, right? If it's percent, if there is a reminder of 2, then odd num will add 1, otherwise 0, right? So let's rerun. Maybe this was the issue, but it's weird, but maybe. Yeah. Now at least num of odds is 2, and 1 to 4, 1 to 4, 4 is excluding, right? So we're not including the sort element. So it's from 1 to 4, so these 3 elements. It says also 2, right? So num is 0. Then from 0 to 4, we say num is 1 because num odds is 3. Makes sense, right? Then again, we say 1, 4, we return 0, 2, we don't do it. 2, 5, 2 is this, 5, like all elements, so 2, 1, 1 should be 2, right? 1 to 5 is 3, so 0 to 5 is 0. It should be this plus this, and then plus whatever number of odds we have equal to k or not. So it should be 2, and we should return 2. So left first plus right first plus odd num (0 to 4 and 1 to 5 it should be 1 and 1. Why the heck? Ah, I see why. This why. Makes sense. Yeah. All right, so run the code, it works, and then submit and see what the scores are. Nice. Should pass. No? Output. Oh, Jesus. Um, should we try to debug this case? Oh, man. 2, so obviously these doesn't count, these doesn't count, these doesn't count. So the first one is count is this, this, this. Yeah, there are many that may count like this and this and this and this and this and this. It should work. I don't understand why not. Am I missing something else? Or the algorithm itself misses something? Okay, so if algorithm doesn't work because we are run out of time, and the debugger will say that the logic itself is wrong, then we're screwed, basically. That's all I can say. But let's see. Yeah, obviously, this one works. That one doesn't work. Oh, man. 0, 2, 0, 0, 0, 1, 3, 0, 0, obviously. So 0, 3 should be 0, 0. 2, 4, 0, 1, yes, because 4 is this one, so it's included. 1 to 4, in this case is 0, 1, unodd, 0 to 4, 0 to 4, 1, 1 to 4, 1, 2 to 4, 1, 3 to 5, 1, 2 to 5, 1. All right, so it skips 1, 1, 1, 1, 1, 1, 1. So first one, 3 to 7. So 3 is this. So 4 to 7. Wait a minute. Yeah, 3 to 7 is this, right? So 3, because this one is inclusive. So maybe the way how I select the first one and the last one, whatever, should be the case anyway. 3 to 7, we say numna is 1 because we have 2. So 3, 4, 5, 6, right? So 7 is excluded. 2 to 7 also remains numna is 2. Why? Because 3 to 7 is 1 and this one is 2, yes. So the problem is we should count unique elements, right? So technically we don't need to return the sum of it. Okay, so all we need is to count the odd numbers for all of the subarrays and then run like it's somewhat linear, but that's what we do, right? So exactly. So if we already have something in memo, right? That was okay. So it's changing logic, but technically it's minor one. So it's more like error. So we don't need to actually set. All we need is just the string, and we don't need to say memo. We need to say checked, right? So if it was checked, we don't need to sum it as part of the nice subarrays because we will double it. So we say set of strings, and we call it checked. Checked key. So what do we return? Let's undo this. Let's keep memo, right? Because it's needed to count correct odd numbers for larger arrays that were not yet traversed. So let's keep memo, but we don't do nothing, but we return something. What do we return? We return make pair of 0, like we don't need to count, and memo key second. Like do not count nice arrays if checked. If already checked. So run code, still should work. No? What the heck? So we didn't change everything completely. So let's see. All right, so we're closing this. And let's see if now we pass it. Ah, dang. Yeah, I guess just too much of overlaps, right? So too many calls. But we were close. I mean, I thought we can do it, and it was sort of linear, but for some reason, it's 14 out of 38. Okay, we keep failing on something we don't need to fail. Oh, man. Yeah, but that was my best guess actually. So I don't know. It looks weird though. Why we don't? Did I miss something? So first of all, we use memo, right? So we don't count arrays twice. So, but we may call them twice, but it will be constant operation. And yeah, and why I don't understand. It's technically elegant. It's concurrent divide. We divide it to tiny pieces until it's key. Then we check, obviously, if it's enough, then we say 1. If not enough, then we say 0. And we also return a number of odd numbers. So next time we just add from side to it. So it's a constant operation to check the number of odd numbers for larger subarray. So I don't really understand. Maybe the way we split, because we just go one side here and one side here. Mm. So yeah, it's so the number of calls itself. It's not the and, right? It's so it's n minus k. That's what we know, right? Assuming k less than n, so it's n square. Plus n square because of these overlaps. So it's quadratic. Well, at least we tried. So, all right. So embarrassment continues. We still can solve easy, medium problems. So it's now what? It's 14 out of 38. Mm-hmm. All right. Thanks, everyone. See you tomorrow.